Hello everyone. I had a couple of requests to make a video for the ionic bonds and covalent bonds practice worksheet that we're working on this week. And so I want to take a few minutes just to go through this. So when you look at the first part here and you see the table here, the chart here, so the first thing you want to do is look at your number of protons, your number of electrons, and specifically your number of valence electrons for each of these elements that are listed here. And so what I'm going to do is go to my periodic table so that I can find my number of protons and also look where the particular atom is located on the periodic table. So when I look at sodium, and I go to the periodic table for sodium, I see that it is number 11. And remember that atomic number gives us our number of protons. And if you have forgotten, don't forget that I've posted your periodic table for you in the course resources and you can access it there. So when I look at sodium, I see its atomic number 11. So that means it has 11 protons. And in a stable atom, the number of protons is equal to the number of electrons. So for sodium, my number of electrons would also be 11. Now, when I get to my number of valence electrons, we have a handy reference for determining how many valence electrons we have based upon the location of our element or our atom on the periodic table. Sodium is in group 1. If we look there, you can see on your periodic table that sodium is in group 1. All group 1 elements have one valence electron. So sodium would have one valence electron. Now if we look at chlorine, chlorine is on the other side of the periodic table. It's a nonmetal. It's all the way on the other side. And we see that chlorine's atomic number is 17. That means it has 17 protons and 17 electrons. Well, it's in group 17. So in order to determine how many valence electrons we have, we look at that second number. Okay, since it's a double-digit group number, we look at the second number, which is 7, and that tells us that chlorine is going to have 7 valence electrons. So for groups 1 and 2, we just look at that number. So all of group 1 atoms would have 1 valence electron. All of group 2 atoms are going to have 2 valence electrons. We skip our transition elements there in the middle, groups 3 through 12. We skip those. We're not really going to do anything with those in terms of Lewis structures or shapes of molecules. So we skip over to 13 through 18. And we look at that second digit there, the one in the ones place there. So group 13 has 3 valence electrons, group 14 has 4, and so on, all the way to group 18. Now when we look at the second part of this assignment, it wants us to write the symbols, draw a Lewis dot structure, draw an arrow, or more to show the transfer of electrons, write the charges, and then write the formula. So remember, with ionic bonds, we are transferring electrons. So what we do when we're looking at Lewis dot structures is we actually show, using the arrows, where those electrons are going. So our first one we have here is sodium plus chlorine. So let me get to my whiteboard. And I will kind of show you how we do these. All right. So I have sodium plus chlorine. And this is, kind of our easiest one that we can look at here. These are relatively simple to do here with sodium and chlorine. We use this one a lot for our examples with ionic bonds. So the first thing I want to do is write my symbol. So I know my symbol for sodium is Na, and my symbol for chlorine is Cl. And if I refer back to the chart that I just filled in, I know that sodium has one valence electron. And you don't have to write this down, but I'm just going to write it down for demonstration purposes here. And chlorine has 7 valence electrons. So when we do Lewis dot structures, when I have just a single valence electron, I like to start here, in the middle, and just put my 1 electron. And I'm going to change colors so that you can see that electron. So there is my 1 valence electron for sodium. Now chlorine, though, has 7, and so when I have more, I'm going to start at the top, and this is really your choice. This is how I was taught to do it, so this is how I continue to do it. But I'm going to start at the top, and I'm going to pair my electrons. So I'm going to go 1, 2, 3, 4, 5, 6, 7. So there's 4 sides here to our symbol, and we're going to pair our electrons and put 2 on each side. So I have 2, 4, 6, and then finally number 7 over here. So now we have to show what's going to happen. Well, we know in an ionic bond, 1 atom loses electrons and 1 atom gains. So because sodium only has 1, it's going to lose that electron. So we're just going to circle it, and we're going to move it over here to chlorine. So now sodium doesn't have that 1 lone valence electron. It drops back down to its lower shell with 8, so it's happy. Chlorine now has 8 valence electrons because it took this 1 from sodium, so it's happy. Because remember, we want to satisfy the octet rule. We want them to have 8 electrons in their valence shell. So since sodium has lost an electron, it has a positive charge now. It has more protons than electrons. So it's going to be +1. And chlorine took an electron, so its charge is going to be -1. And so our new chemical formula for this is going to be NaCl. And just to kind of practice our naming, that's going to be sodium chloride. Okay. So a Lewis structure or Lewis dot structure is how we show the number of valence electrons that we have in a particular atom. So let's look at another example here. Let's look at magnesium and iodine. So we'll look at magnesium plus iodine. I'm going to get my symbols here. Magnesium is Mg, iodine is I. Magnesium is in group 2, so I know that it's going to have 2 valence electrons. So I'm going to put those right there. And then, oops, didn't mean to draw all those other little dots right there. And then iodine is in group 17, so it has 7, just like chlorine. So I'll start here, 1, 2, 3, 4, 5, 6, 7. Now this time we see that magnesium has 2, iodine has 7. Well, iodine can only take 1 more. So iodine can only have 1 more valence electron, but magnesium has to get rid of both of its valence electrons. So what we're going to have to do is add another atom of iodine so that there's room enough for magnesium to get rid of both of its valence electrons. So what's going to happen now is this first valence electron will join right over here to this top iodine, and the one here will go down here. So now magnesium is back happy with 8 valence electrons because it's going to drop down to its lower shell. This iodine has 8 and this iodine has 8. So this time we had to add an extra atom because our goal here is to make our overall charge on our compound to be 0. So magnesium is +2, and each iodine is -1, and if we say +2 -1 -1, that gets us to 0, and that's always our goal with an ionic bond. So this time our formula is MgI with a subscript 2, because we have to indicate that we have 2 magnesium atoms that are going to have to be combined with magnesium in order to make this an overall neutral compound. Okay, so that's how you do Lewis dot structures when we're looking at ionic bonds. The second page of this is very similar to start out with covalent bonds, but remember, with covalent bonds they share electrons and don't transfer. So you're going to fill out the chart. So if we look at carbon, we know carbon is atomic number 6. So carbon has 6 protons, 6 electrons. It has 4 valence electrons. It's in group 14. It has 4 valence electrons. It needs 8 to be happy, to fulfill that octet rule. So it needs 4 more. Okay, so carbon has 4. It needs 4 more. If we look at hydrogen, hydrogen is atomic number 1, so it has 1 proton, 1 electron. It has 1 valence electron. It needs 1 more. Hydrogen and helium only need 2 electrons to be happy, because they only have that first orbital. They only have the s orbital, which holds 2 electrons. So they only need 2 to be happy. So hydrogen has 1 valence electron. It needs 1 more to be happy. So when we do the Lewis dot structures for our covalent bonds, they're very similar, but we're not going to use arrows to show the transfer of electrons because we're not transferring, we're sharing. So if we look at hydrogen and hydrogen, here's hydrogen, here's my other hydrogen. Okay, and they have 1 valence electron each, and so I'm going to put both of those here in the middle. And now what I basically have to do is, instead of showing a transfer of electrons, I'm just going to move these atoms closer together so that their valence shells overlap. And now what that does is it lines up this pair of electrons right there so that they can share those. So I'm going to circle those to show that those are the pair that are being shared, and I'm going to use my bond notation here to indicate that that is a single bond. So I draw 1 little dash there between my 2 hydrogens to indicate that that's a single covalent bond, that they're sharing those. And my formula then is going to be H2, because I have 2 atoms of hydrogen. Now when you look at some of these others, like if you look at, for instance, hydrogen and oxygen, nitrogen and hydrogen, carbon and hydrogen, you're going to have to do these similarly to how you did magnesium and iodine, so that you make sure that each specific atom is happy, that they all have 8, except for hydrogen, which again needs 2, that they have 8 electrons each, so that they can be happy. And so sometimes they'll share 1 pair of electrons, like our example here. Sometimes they'll share 2 pair of electrons, or they'll share 4, or sometimes they'll share 6 electrons or 3 pair of electrons. And I'll show you more of that in the next video when we look at the shapes of molecules.